Chapter 16, Part 2, we are going to continue our work with our mean or expected value and standard deviation. In this video, we're going to talk about operations with mean and standard deviation. So by operations, we mean adding, subtracting, multiplying. So the first one we'll look at is adding or subtracting a constant. So when we're adding or subtracting a constant from the data, it will shift the mean, but it does not change the variance or the standard deviation. So I'm going to put this in notation here. If I was finding the mean or the expected value of a random variable, which I'm just going to call x, and I'm adding or subtracting a constant. So I'm going to do a plus or minus here and use just a lowercase c to represent a constant. So that could be any number there. What happens is you would keep your old expected value, your old mean, and you would just add or subtract whatever that constant is. So if we were adding 4 on whatever my old mean was, I would just add 4, and that would give me my new average. This adding or subtracting does not change the variance or the standard deviation. I'm just going to write the formula for variance because we know that once we had variance, we would just square root it to find the standard deviation. So if I'm finding the variance of my random variable x, but I'm adding or subtracting a constant, again, just using that lowercase c, this adding or subtracting does not change the variance, so this would just remain variance of x. We've seen this idea before where adding or subtracting changes the measure of your center because what you're doing is taking that data and just shifting it over. But by adding or subtracting, you are not changing the spread. It doesn't change how spread out things are. It's just changing where that average or that mean is located. So example 1, in that opener that we just did, we looked at Soda's Pizza Shop. It was offering specials to their customers. This is just the same problem again. They earned $50 for a black ace, $20 for a face card that is black, and $0 for a red card. We discovered that the average discount was $4.23 with a variance of $124.41, standard deviation of $11.15. So suppose that for several weeks, the restaurant has also been distributing coupons worth $5 off any one meal, so one per table. If every couple has a coupon, what will the mean and the standard deviation of the total discounts they receive? So in the opener, the random variable that we were looking at was representing the discount that people were getting. So I would have x represent discount, and I'm going to say from the cards. That was what we were using for x. Now what we're doing is we're adding an additional discount. People are getting an additional $5 off. So we want to find the mean and the standard deviation. So when I go to find the mean of my random variable x, the discount, we're now adding an additional $5 off, so I'm going to do plus 5. Expected value is pretty easy. We're going to take our old average, which was $4.23, and add on the additional $5 that we're expecting everybody to have, giving me a new expected value of $9.23. I like expected value or average. I think it typically makes sense. We're saying that if everybody has a $5 off discount, they have this coupon, I'm expecting my average to increase by $5. Things get a little weird with variance. It's always a little bit trickier with variance. So in this case, what we're doing is finding the variance of our random variable plus the additional $5 coupon. Now we said up here that adding or subtracting of a constant does not change the variance. So this variance of x plus 5 should just be equal to my old variance, which we found in the opener that variance was 124.41. So to find my new standard deviation, and technically this is the standard deviation of x plus 5, it's just the square root of my variance, which was 11.15. So again, adding or subtracting, it will change your average, but it will not change your standard deviation. Next up, we'll talk about multiplying by a constant. So multiplying each value of a random variable by a constant multiplies the mean by that constant. So I'm going to stop there for a second. When I'm finding my expected value, this time I'm going to be taking my random variable and multiplying it by a constant. So I'm going to write this as c, which is my constant, times x, or cx. Okay, to find this, what we're going to do is take that constant and just multiply it with the old expected value. So whatever the old average was, you're just going to multiply it by that constant. Now, like we said, variances are kind of weird. So when I'm finding the variance of cx, so my random variable times x, because variance is a measure of squared units, what we need to do is take that constant, so that's c, and square it. Then we can multiply by the old variance. So in example 2, we're still working with my pizza shop. When two couples dine together on a single check, the restaurant will double the discount offer. So if two people come in and dine together, we are going to double the discount. What that means is that we're going to multiply the discount by 2. We want to find what the new mean and standard deviation of these discounts would be for groups. So we'll start with finding expected value. My constant this time is 2 because I'm doubling the discount. So what I'm going to do is just take 2 and multiply it by my old expected value. That old average again was the $4.23. So 2 times $4.23 should give me $8.46. Here is my new expected discount for these groups. A variance, still doing 2 times the random variable. Again, because variance is a little bit weird, instead of just taking 2 times the variance, we have to do 2 squared times the old variance. 2 squared is 4, and then I'm multiplying by my old variance, which was 124.41. Four times 124.41 gives me 497.64. From there, I want to find the standard deviation, and I'm going to write this as standard deviation of 2x because it's still double the discount that I was looking at. To find this, I'm going to square root that variance, and we get a standard deviation of $22.31. On this next page, we are now going to be looking at adding and subtracting separate random variables. So we're going to have 2 different random variables this time. That might mean that we have 2 different games that are happening. You might be flipping a coin and rolling a dice. There might be 2 restaurants involved. There's 2 separate random variables. Whenever you're working with these 2 separate random variables, make sure you have different capital letters. So you might have X and Y. You might have L and M. You could have any letters there, but make sure you're using different capital letters for those different random variables. So when we're adding or subtracting these individual random variables, the mean of the sum of two random variables is the sum of the means. So if we're adding the two together, my average is just going to be the two averages added together. And the same thing is true for the difference. The mean of the difference is just the difference of the means. So in notation, here's what I mean. If I'm finding the expected value of, I'm going to do adding and subtracting together for two random variables, let's just use x and y. So maybe I'm taking x, adding or subtracting y. To find this, what we would do is take the average or the expected value for x, and we would either add or subtract the expected value of y. Okay, what's interesting is that variance was a little bit different. So if the random variables are independent, so if we believe that whatever's happening in event y has no impact on event x and vice versa, then the variance of the sum or difference is always the sum. Variances always add. If you're a person that highlights, I would highlight this, I would put some stars around it. This is probably one of the trickiest parts of variances, is that when you're adding or subtracting, the variance always adds. Variance is a measure of spread. It can never be negative, so it is always going to add. So notation-wise, if I'm finding the variance of either x plus or minus y, we're always going to separate those two variances. So I'll take the variance of x, and I always add to the variance of y. Variance is a measure of variability. It's how spread out things are. It's, looking at the chances that something goes a little bit awry. If I have two random variables that are happening at the same time, whether I'm adding them or subtracting them, the chances that something goes wrong, or the chance of there being more options and things being more spread out, should always be increasing. So regardless of whether you're adding or subtracting, your variances right here will always, always add. So in our example, it says, same kind of thing, still working with my pizza shop. I have an average of $4.23, standard deviation of 11.15. Just up the street, Miss Mollahan opens up her own restaurant. It's called Mollahan's Meals, and it's also having a competing promotion. I think that's a little rude of her, but whatever. At this restaurant, a couple can randomly select a poker chip from a bag in order to receive a discount. The manager of this restaurant claims that the discounts vary with an average of $3. So for Mollahan's Meals, she has an average of $3 with a standard deviation of 10. How much more money can you expect to save at Soda's Pizza Shop, and what is the standard deviation? Now, we do have two different random variables here, so I want to make sure that I start with talking about what capital letters I'm going to use for both of these. So Soda's Pizza Shop, I'm going to have that be represented by S. So we'll say S represents Soda's Shop. And for Mollahan's Meals, let's use M. Represents Mollahan. So there are my two random variables, and you didn't have to use S and M. You could use X and Y, whatever the case may be. Okay, I'm trying to find how much more money I can expect to save at Soda's versus Mollahan's. So when I'm finding how much more I expect to save at one versus the other, what I'm really doing is subtracting. So I'm going to take the amount of money that I expect to save at Soda's and subtract what I expect for Mollahan. Okay, what I'm going to do here is just split these up. So I have my expected value of Soda minus the expected value of Mollahan. For Soto, my average was the $4.23. Malahan was just $3. That gives me a difference of $1.23. So far, I can expect to save $1.23 more at Soto's restaurant than at Miss Malahan's. Okay, switching gears and looking to find the standard deviation. Remember, I do have to find that variance first. So I'm going to find the variance of S minus M. This is the hard part. Remember that variances, even though I'm subtracting here, when I separate them, it's always addition. So really what I'm going to do here is take the variance of Soto's and add it to the variance of Malahan. Okay, the variance for Soto, we already know, is 124.41. For Malahan, they told me the standard deviation, but they did not tell me what that variance is. Remember that when you're given standard deviation, if you want to find variance, all you would have to do is take that standard deviation and square it. So 10 squared would give me 100. So that means my new variance is now 224.41. Once I have that variance, I can now find the standard deviation of the difference by square rooting 224.41. That gives me 14.98 as my new standard deviation. Okay, we have one more example here. Still working with adding and subtracting of separate random variables. So example 4 says, Soto's Pizza Shop is offering specials to their customers as described. The owner, myself, is planning to serve 40 customers this Friday evening. It's going to be a crazy Friday at Soto's Pizza Shop. We want to find the expected total of the discounts and that standard deviation. So what we've been doing so far is looking at just one customer, right? What can I expect the discount or the standard deviation to be for one individual person? Now I'm saying that I want to know what's happening in total if I can serve these 40 customers. So if X, well, I'm going to use S. Let's say that S represents just one person at Soto's shop. I need this to happen 40 times. So to find the expected value, what we're going to do is look at one customer. I'm going to say S1 plus another customer, S2, plus a third customer, S3, and we're going to do this on and on and on and on until I get to 40 customers. Now I'm treating each of these customers as their own random variable. What's nice though is it's addition, so I can just split it up. So I would have the expected value of the first customer plus the expected value of the second customer. And again, I would continue this all the way until I get to the 40th customer. Okay, well, what was my expected value for just one customer? It was the $4.23. On average, I expect to pay the same for that second customer, and we would continue all the way down to the 40th customer. Now in your calculator, you can sit here and type in 4.23 plus 4.23 plus 4.23 40 times, or using just what we know about math, we could just type in 40 times 4.23. I'm going to save myself some time and just type that in instead. Okay, that gives me 169.2. Okay, what that means is that if I serve these 40 customers, the total discount that I can expect to pay out would be around $169.2. Okay, we also want to find the standard deviation. Again, before standard deviation, we always need variance. And I'm using that same idea here, that I have these 40 separate customers, meaning I have 40 separate random variables. And remember that variances are always adding. This one is already addition, so I don't have to think too hard. I'm going to split this up into the variance of the first customer plus the variance of the second customer plus all the way down to the variance of the 40th customer. The variance of that first customer was 124.41. I have that happening for my second customer all the way down to the 40th. Again, I don't want to sit here and type this all into my calculator 40 times, so I'm just going to do 40 times 124.41, which gives me $4,976.4. So I know that my standard deviation of all these different customers is the square root of that. Which gives me $70.54. Okay, I do want to point out here that what we did was separate each random variable using addition. Yes, we did end up using multiplication, but that was simply just to save us time, not typing everything into our calculator. This problem would look very different if we were trying to find, let's say we were trying to find the expected value of 40 times the customer. Okay, if it was 40 times the customer, then yes, my expected value would still be the same. But variance would look different if we were doing 40 times that discount. Because remember, with that variance, I would have to take 40 and square it before I multiply by the variance. So I would be doing here 40 squared times my old variance, which was the 124.41, which is a huge number. And then I'd be square rooting that to get the standard deviation. So I would have a standard deviation of 446.17. That is a lot different than a $70 variance or standard deviation. So watch out here. We're not multiplying what we're expecting to happen by 40. What we're doing is looking at 40 different random variables, but we're just using that multiplication as a little bit of a shortcut for our calculator.